All right, so let's do the coordinate geometry drill on page 102. We have 5 questions. This is really a pretty interesting drill. So let's start with number 1. What is the distance between the points 7, 8 and 10, 12? And when you're thinking about distance between 2 points, what you're probably going to end up with is some sort of diagonal line like this, and then your x-axis and your y-axis are going to create a right triangle. And so this is going to basically be your height, this is going to be your base, and this is going to be the hypotenuse. So let's try this one and see what we get for number 1 here. Let's use the Pythagorean theorem. And so we can see that on the x-axis, let's plot these 2 points out real quick and let's see what we get, okay? So we're looking for point 7, 8. So let's say that's 7, let's say that's 8, and let's come right here. And then we're looking for point 10, 12. So take 10 over here and say 12 is about up here. So we're looking for a point like about this. And this is the distance we're trying to get. Now, what we can do is we can find out what is the distance in terms of the x-axis and the distance in terms of the y-axis. And again, this is height, this is base, and we use the Pythagorean theorem. So we can see that on the x-axis, we go from this point, which is 10, to this point, which is 7, right? So that's 3 on the x-axis. And then on the y-axis, we go from a high point of 12 to 8. So that's 4. So we have a 3, 4, 5 triangle. And the distance is, let's make this correct now, the distance is 5. So Pythagorean theorem, basically what you're looking for. And the distance formula is simply to take the distance from the y coordinate, right? Square that. The distance of the x coordinate, square that. Add these two together, and then take the square root. So 16 plus 9 is 25. Take the square root, and that equals 5. So the Pythagorean theorem is to take the distance between the 2 y points plus the distance between the 2 x points, each of those squared, and then take the square root. All right, second, what is the area of a quadrilateral with the vertices 5, 4, 8, 8, 5, 12, and 2, 8? So look at our drawing over here and look at the different points, okay? So this one is going to be 8, 8. This one is going to be 2, 8. Then we have 5, 12, and we have 5, 4. Okay? Now, what are the distances in terms of the vertical and in terms of the horizontal? So the vertical is going to be a distance of 8, right? The total length there is going to be 8 from 12 to 4. And for the horizontal, it's from 2 to 8. So this is going to give us a distance of 6. So we have 8 and we have 6. Now, there's no real way to get that area of that diamond in a nice fashion. So what we're going to do is we're going to break this down into a bunch of triangles, of course, always triangles. So this triangle would be 4 and 4 for the height. Those are 2 separate triangles. And obviously you'd have a base of 3 right here and a base of 3 right here. So you can see that if we take any of these particular triangles, like this one, we have a base of 3, height of 4, and that's going to be a 5. Base of 3, height of 4, that's going to be a 5, and so forth. So there are 4 triangles. We want to know what's the area. So we have 4 triangles, and each of them has a base of 3 and a height of 4. So that's 12 divided by 2 equals 6, and there are 4 of those, and that's 24. The perimeter of this thing is going to be 20, because we have all those 5s, and the area is going to be 24. That's a multiplication. All right, next on the drill, we have number 3. At what point do lines y equals 2x plus 6 and y equals 4x plus 2 intersect? Well, listen, when we're looking for the point where they intersect, that's the point where the y coordinate is going to be equal. So set these two things equal. where does 2x plus 6 equal 4x plus 2? That's it. That's all we've got to do. Well, if we subtract 2 from this side and subtract 2x from this side, we get 4 equals 2x, or x is 2. So now we know that x is 2 where they intercept. All you have to do then is plug 2 into either of these, like for example right here. So y equals 4x plus 2, plug in a 2 for x, y equals 8 plus 2, y equals 10. The point where they intersect is 2 and 10. X coordinate 2, y coordinate 10. This is going to come up in just a moment when we have to finish up another coordinate drill. Number 4, again, these drills are really actually pretty complicated, GMAT questions here, but a circle with a diameter of 10 is centered on the origin. So here we've got an origin right here, and we've got a circle like this, and the diameter right across here is going to be 10. Okay? Now, which of the following points are on the circle? Well, if the diameter is 10, then we know that the radius at any given point is going to be 5. Wherever it's going to be, that radius is going to be 5. So what we can quickly see is that A works because 5, 0 is going to work. That's going to be what? Right here, exactly on there. 5, 5 is not going to work because 5, 5 would be up here somewhere. That's absolutely not going to happen. And negative 3, 4, yes, this will work because negative 3, 4 is going to be about there, right? Because we've got a negative 3 down here and a 4 here, leaves us with a 5, 3, 4, 5 triangle. So that works. The question just comes down to D and E at this point. Now remember, what we have to total is 25, because as you can see, if the radius is 5, right, 3 squared, 4 squared gives you 25. 3 squared plus 4 squared equals 25. We're looking for anything that gives us 25. So does 5, 0. 5 squared plus 0 squared equals 25. So we need for either of these to give us a 0. So let's try. What about B equals, so we have D, we have 1 and negative 2 square root of 6. So let's try it. The distance from the origin is 2 root 6, we square that. And then whatever B squared is, we're going to determine it has to equal 25. You see that? This is going to tell us which point is acceptable to pair with 2 root 6. So when you square 2 root 6, you get 4 times the root 6 is 24, right? So when you square root of 6, you get 6. So 4 times 6 is 24 plus B squared equals 25. Aha! B has to equal 1 or negative 1. That means D is on the circle as well. Obviously, E is not going to be on the circle because negative 2 is too far away. Wow, this drill is quite the thing, right? And we've got one more, and look at the drawing that I did for this one. Now, you wouldn't have to do all of this on test day, but I'm going to try to walk you through this a little bit. What's the area of the triangle formed by these lines? Y equals 2x minus 2. Y equals minus 1/2 x plus 8, and y equals 0. So in blue you can see I did the first line, y equals 0, that's just going to be the x-axis, because whatever x is, y is always 0. So that's your x-axis, so that's the blue line. That forms one side of the triangle. The other sides of the triangle, a negative slope, like the green equation here, negative 1/2 x, a negative slope goes down to the right. A positive slope goes up to the right. So you can see that there's going to be 3 points of intersection. And your 3 points of intersection are going to be where the green line intersects the x-axis. So where y equals 0, what is x? Where the red line intersects the x-axis, so where y equals 0, what is x? And for the height up here, the peak of the triangle, it's going to be the intersection of the two lines, okay? So let's start with the green line. Where are we going to intersect the x-axis? Well, again, if you set y equal to 0, you'll get what x is when y is 0. So say 0 equals negative 1/2 x plus 8. Subtract 8 from both sides, divide by negative 1/2, you get 16 equals x. So 16, 0 is going to be our point for that one. On the red one here, if we have y equals 0, we have 2x minus 2 equals 0. So you add 2 because you're trying to move that over, right? So you add 2 and then you divide by 2. So x is equal to 1. So this point is 1, 0, and that point is 16, 0. So this distance is going to be a distance of 15. And then the actual intersection comes where we have these two lines equal. That's the point where they intersect. So over here you can see I've made 2x minus 2 equal to negative 1/2 x plus 8 to find this intersection. What we do is we add a 1/2 x to this side and we add 2 to this side. We have 10 is equal to 5 over 2x, and then we say 5x is equal to 20, x is equal to 4. So when x is equal to 4, plug it back in, plug that back in. So look, y is equal to 2 times 4 and then minus 2. And that means y is equal to 6. So where x is 4, y is 6. So 4, 6 is the point where the peak is. And that means that our height is going to be 6. And again, we have 15 for our base. And of course, 15 times 6 divided by 2 is going to be equal to, make a 3, 45. Wow. So that's the last one on our coordinate geometry drill. Really, really interesting and actually difficult problems on that drill. I hope you liked it.